Hello and welcome to the Sky Chemicals Peracide training video. My name's Stuart Bown. I'm the company trainer and the regulatory administrator, and I will be delivering the training for this video. The video will cover the basics of using Peracide, as well as some of the science and background of it. So the first section of this video is going to be about what Peracide actually is and a bit of background on the tablets. Peracide is a dry tablet formulation. It comes in tablet form, comparable to the existing chlorine tablets in that they dissolve in water, form the disinfectants, and they are usable from there. The tablet system provides a very good measured dosing system. It makes creating the correct strength of solution very, very straightforward. As a simple number of tablets to an amount of water will create this strength. That will be covered in more detail a bit later on. The tablets are stable whilst dry. There's no peracetic acid in the dry tablets. It's not until they're added to water that the components in there will begin reacting together and form peracetic acid in situ. Peracetic acid is an incredibly potent biocide. In the laboratory tests that we performed at 4000 ppm, it is sporicidal in 15 seconds to a log-7 kill rate. So in 15 seconds, it will take out 99.99999% of spores. It's been used in food applications since the 1950s, and it's been used in water treatment since the 1970s. In the existing format and way of it being used, it is a mixture of hydrogen peroxide and acetic acid, normally of a 5 to 15% strength. This makes preformed peracetic acid rather unpleasant to handle. It can be corrosive, oxidising, requires an awful lot of personal protective equipment and very, very careful handling procedures. So Sky Chemicals came up with a tablet formulation that moves away from having to dilute down a hazardous material. The tablets start out with no peracetic acid in them, and they form from the precursors that are in the tablets when they dissolve in water, so the tablets are safe to handle. Peracide contains a surfactant to assist with dirt removal and general cleaning. There's no pre-clean needed, no wipe down needed after cleaning because there are no harmful residues, and it's a one-part cleaning system. The presence of surfactant assists with the antimicrobial properties by helping to wet surfaces, meaning that the Peracide comes into contact with the entire area and kills all of the pathogens. Peracide features a proprietary colour activation system to assist with usage, to help with knowing that the solution is active, to allow auditing and to make sure everybody is happy with the solution. We will cover the colour changing system in more detail in a wee while when we go through the demonstration. The Peracide solution contains a fragrance for a pleasant cleaning aroma. Main reason for this is simply to provide a nice smell. Your standard range of kitchen cleaning products tend to smell of pine or lemon, so the fragrance in this is apple. The other reason is a slight masking agent. Peracide contains no chlorine, so it does not give off chlorine gas, but as part of the breakdown of the peracetic acid, it does give off acetic acid, so there is a slight vinegar smell for a short while. The apple fragrance is there to mask the vinegar smell a little bit, and also, as I said, to create a nice smell. Peracide kills all known microorganisms. Due to its oxidative nature and its mode of action, it will work on bacteria, viruses, fungi, spores, and it will even take out biofilms. We'll cover the chemistry in detail in a short while. Peracide works in clean and dirty conditions. In the laboratory tests that have been performed on it, the effect of soiling on Peracide's activity is minimal. The log-7 ratings still hold even in the soil conditions in laboratory tests. In comparison, chlorine is elemental, so in the presence of dirt, the chlorine will actually react with the dirt, latch onto it, and once the chlorine has been taken up, it can take part in no further reactions and doesn't have any more biocidal effect. Quaternary ammoniums are heavily affected by soiling. It's a large molecule. When it latches onto the dirt particles, it's basically inactivated and won't do any more disinfecting. Peracide is ideal for all hard surfaces. It can be used on metals, glass, plastics, phones, keyboards, high touch points, anything that's around. The general rule when cleaning electronics, make sure there's no free water coming from the cloth. It means electricity and water is not a good combination, but as long as the cloth is wrung out, it is ideal for cleaning down any hard surface, including touch points, electronics, telephone receivers, and anything else. It can also be used on soft furnishings. It will not damage them like chlorine does, so seat coverings, screens, pleather, the usual range of soft furnishings that are around in clinical facilities can be wiped down with Peracide. It has a minimal bleaching effect, whereas chlorine compounds will remove the colours from materials very, very quickly. The bleaching time of hypochlorite tends to be of the order of minutes to hours. The bleaching time for the Peracide solution is of the order of months to years. It is usable on all soft furnishings. Peracide is minimally corrosive. The current cleaning materials in use have severe problems with corrosions. Chlorine compounds attack metals. They will take apart plastics over time, and they will shorten the lifetime of soft furnishings and many fixtures and fittings. Peracetic acid, at the strengths it is used to be biocidal, is not particularly corrosive. It doesn't attack metals particularly quickly and doesn't harm plastics. In addition, the formulation contains a corrosion inhibitor to further negate any corrosivity that the solution may have. The laboratory tests were done on steel strips shows Peracide to be much less corroding than the chlorine tablets and chlorine dioxide solutions. In the laboratory tests, chlorine dioxide will take apart stainless steel very, very quickly. Chlorine tablets will take apart stainless steel quite quickly and lead to a lot of rust. And after 4 weeks in the solution of Peracide, the stainless steel tablets are minimally rusted. So we are confident that it will have minimal effect on the infrastructure. In addition to its effectiveness, one of the key features of Peracide and peracetic acid is its very, very low toxicity and that it doesn't create any particularly hazardous byproducts of cleaning. Quaternary ammoniums are persistent and stay on surfaces. Chlorine-containing compounds will create chloroalkanes, chloroacetic acid, chloroamines, and release chlorine gas during use, which is not particularly good for the user. Chlorine dioxide doesn't create quite as many chlorinated byproducts of cleaning, but it still leaves chlorite and chlorate salts behind and has a very large vapour pressure, so the end user will be breathing in rather a large amount of chlorine dioxide. In contrast, peracetic acid is the organic peroxide of acetic acid. It's highly soluble and has a very low vapour pressure, so basically the peracetic acid will stay in solution. Anything that comes out of solution is very unstable once it gets in the air, and it will rapidly degrade into acetic acid, oxygen and water. So basically vinegar. The solution itself will break down to produce acetic acid, water and oxygen, and the environmental fate of acetic acid is very well understood. It's not a persistent chemical and it doesn't have any real toxicity in the environment. There are no compounds in the formulation that can bioaccumulate or show any environmental toxicity. The breakdown product primarily is vinegar. For reference, a 4000 ppm solution could not produce more than 0.4% peracetic acid. Therefore, it cannot produce more than 0.4% acetic acid. To put into context the strength of acetic acid that's actually in the spent solution, chip shop vinegar is normally 4 to 8% acetic acid. The strongest solution of Peracide will ever be used at is 4000 ppm, so the maximum amount of acetic acid that could be in solution is 0.4%. This makes the spent peracetic acid solution about 1/10 of the strength of chip shop vinegar, so it is not harmful to the environment.